Recently, Stefan over at CNC Kitchen launched a website that allows you to add a 3D printable texture to a 3D model. He mentioned trying to use Blender to achieve this, but in his own words he admitted that he was too lazy to learn it. I've been making printable textures with Blender for a few years, so I thought I'd share the basic setup that I use to achieve this. There are several methods to approach this, but this is the easiest that I've found. Let's start with the basic model that's still three-dimensional. The torus is nice and more interesting than a cube or sphere. You can use the inbuilt monkey mesh, but it isn't manifold to start with, so generally isn't 3D printable. Okay, so let's add this torus to it. Now, I tend to model at 1 Blender unit per millimeter, so that's what I'm going to use here. I've set major segments and minor segments pretty high, so it's fairly smooth, major radius of 50 and minor radius of 20. So it should be approximately 140 millimeters across. So this won't give you enough geometry to make a nice surface texture to begin with. So there are a few ways of adding more detail, more geometry to it. There are several options under the modifier. You can, for example, go to the remesh, but that generally remodels everything at 0.1 Blender units, which might be pretty small for the size you're set at, and as a result could end up being very slow. You can also subdivide the surface, but that gives you no control over the size of the geometry. So what I tend to do is do it directly within geometry nodes itself. And new. Okay, so let's remesh this torus at a certain size. So here what you want to do is, I've set space to be the search function. You may need to change your preferences to do this. So what I'm going to do is mesh to volume. This turns it into a volume, and you can then change the size. So I'm just going to quickly disconnect that, because you don't want to accidentally put the wrong size in and again crash your computer. So size 0.3 is okay, but for this let's change it to say 0.6. Next step will be volume to mesh. So this turns it back into a mesh again. If you have it set to grid, then it just copies the voxel size here as the output. Okay, so now it's a solid again, but as you can see it's got this ringing. So one way to get rid of that is if you add a set position node. This will move all of the vertices to a certain position, and I'm going to do geometry proximity. This is probably the node I use most of all. I take the original geometry, plug it in, make sure faces, and then plug the position into position, and as you can see, look closely, it maintains the remeshed size, but everything is now back to the original mesh. Okay, and let's say we want to control the voxel size from within. You can just click and drag this to the group input, and now over here you see you'll be able to change it, so it's 0.6. Okay, now that we've got a nice uniform mesh, what I'm going to do is I'm going to make a new geometry nodes group, and I'm going to use this now to apply the texture. So it's actually surprisingly simple. What you want to do is another set position node, another set position, and then a normal mode. So you don't plug it in yet. So each of these vertices has a normal, which is a direction that's generally pointing outwards. I haven't done anything weird with the normal, so right now they should just be nice and uniform. Okay, so what we want to do is take the normal and apply it to the offset. But if we put it in directly, what we'll find is everything just expands out by 1 unit, because the normal is set to as a vector 1 unit length long. So what we want to do is vector math, plug that in, and you can change that to scale. And now it's set to 1, but we can change it. But the cool thing about this is that you can change the input, the scaling input, based on the position. And I'll just show you how. Okay, so let's do a really simple sort of fuzzy skin style design. And to do that, all you need to do is add a noise texture. Take the noise texture, make sure it's normalized, and take the factor, plug it in, and it will be a mess. Okay, that's fine, but it's noisy and there's no particular structure to it. But if we reduce down the scale, you see this is a much sort of lower sort of noise. And if we drop the detail down, you'll see it's a much more smooth, wavy sort of texture. And there you go. That would be the simplest implementation of adding a surface texture. As you see, it is in the actual geometry. So if you exported this right now as an STL or OBJ or something and took it into your slicer, you'd be able to print it. Now, at the scale that it is, it probably wouldn't work so well on an FDM printer, but for a resin printer, it worked really well. Okay, let's say you wanted to make this pattern deeper. So what we can do is we can add just a simple math node now in here, and then take that and multiply it. And as you see, as you change that, it changes the depth. So let's plug that in, and that will now be a value that we set the depth to. Okay. What else can I show you? Well, one interesting thing you can do is if you add a float curve to this, plug that in, doesn't do anything to begin with, but you can start changing these values. You start getting more interesting effects. So 3. You can make bumps like that. See? So the noise texture is the most basic one, most basic node, but the other basic node that you probably want to use is the Voronoi texture. So what this does is it distributes a series of points over the surface, over the volume, and you can then do various things with that information. So if we just simply plug the distance in, and again reduce the scale to something useful. See, you're starting to get a faceted pattern like that. And then if we change this to a negative value, see, it starts popping out like that. Generally with the F1 Voronoi, you might want to put it through a power node, so you want to give it a power of 2, and that helps smooth it out, and now it looks like a series of bubbles rather than a point. You can also do things like F2 and smooth F1, that smooths everything out. So you get this really bumpy thing. You can also things like the distance to edge. Let's make that quiet. So you can get these interesting patterns. So this would be a stony sort of pattern. It would be good for, as I say, a grip. You can also combine these textures together. So if we take a noise texture and take the color factor and plug it into the Voronoi, you again get an interesting pattern. Though actually I think it might be better going the other way around. You take the Voronoi texture, plug it into the vector. Yeah. That's some more interesting. Let's increase the voxel size to, well, decrease the voxel size. Something like 0.3. See? Interesting patterns. And if we do something like smooth F1, you get this sort of these weird alien-esque kind of textures. Oh, and you can also add distortion. So if we change that to 1, yeah, you see, if you have a distortion of 0, it's like that. But then if you, yeah, distortion of 0, but if you increase it, it's like this. People use these nodes to make a whole range of different things. So if you look up procedural textures for Blender and things like November, you will see lots of examples of people making amazing things using this sort of maths, except they tend to use it in the shading node, in the shading workspace, whereas this is the geometry node workspace. I've put up an add-on, a geometry nodes add-on on SuperHive Market, which has about 19 different textures, I think, and they go into more detail, many more options, and other interesting things like reaction diffusion patterns and ones where you can control. Yeah, actually, I'll show that next. You can control where the pattern goes based on vertex group data. Okay, so yeah, let's try doing vertex group data. So to do that, I'll apply this. There are ways to transfer vertex group data over through this, but that's more complicated, so I'm not going to do that now. I think at 0.3 that's fine, so let's apply that. Okay, so if we were to hide this, we're back to this thing with the very high density mesh. So if I go into edit mode, and then let's select, first of all, let's go into wireframe mode so I can select through it, and then let's select box select like this, and then we go to the data and go to vertex groups and select, group assign of weight of 1. Cool. Okay, so you can't see anything now, but if we go and do a named attribute and we select group and exists, okay, no, because everything is in there, so we need to use the compare node. Compare greater than 0.01 attribute and take that result. You'll see. You see now it's only the parts that are painted that were painted with that vertex group, which you can see. Now generally, as you can see, the edge is pretty nasty, so let's apply a way of blending it. So because that group data was 1, what we can do is we can take the multiply, we can do another multiply here, take the attribute, plug that in. Okay, so still horrible, messy, but we can then do a blur attribute, blur it, and even 1 has has now blended it, but we can do it a few more times. Now see, so there's a smoothness to it, and it's only affecting the strength of the texture, so it's not affecting the texture in any other way. Cool. And there's lots of other ways you can play with this, but these are a few simple ones to get started. And because you've got different attributes, you can have multiple different textures all layered on the same thing. I did a version of the Blender Monkey head with 7 different textures on it, and all arranged via this Voronoi scattering and everything. And if you want to see some examples, my short videos on YouTube, I've got a few examples on there, various different patterns that you can do. So yeah, if you want to see some more, check those out, and maybe take a look at the Super Hive market, because that will have 19 different ways of 19 different patterns, so you can see how I made all of those and see if you can modify them for your own needs. Okay, cool.